to talk about recursive equations. But first we've got to do some definitions. So let's start by a pattern. You've known these since kindergarten. It's an orderly sequence consisting of a number of repeated events. Next we've got a sequence. It's a set of numbers in a specific order. Then we have terms. It's the number or elements in a sequence. Now, two definitions you may not know. One is a recursive equation. It's an equation that shows how to calculate the value of the next term in a sequence from the value of the current term. And that's what we're really going to work on in this video. Also, we have explicit equation. That's an equation that tells how to calculate an output value based on an input value. So this is what we're going to be working on, specifically recursive equations. All right, so very important concept number one. We can write recursive equations from sequences, tables, or visual patterns, and we'll do an example of all three in this video. Very important concept number two. To write a recursive equation, we're going to use this formula. Start at, and you'll put the number in which you start. Then you're going to say next equals now, then you're going to do the pattern. So this is the formula I want you to get used to using, for now at least. Start at, you'll put your number, then next equals now, whatever your pattern is. Whoa. Alright, so here we go. Here we're going to just start with a sequence. So you can see your sequence here is 5, 10, 15, 20. Hopefully you can see that we're going up by 5. So we would say we start at 5. To write our pattern, we would say next equals now plus 5. Okay, what about the next one? 2, 4, 8, 10. This time we're doing what? Here we went up by 2. Here we went up by 4. Here we went up by 2. I actually think I may have left out a 2, a 6 here when I wrote my problem. So we would say start at 2, and we would say next equals now plus 2. So they're not always addition, just my examples. So let's look at some more. Okay, now we're going to look at tables. So what's happening here? Look at your difference. We start at -3, our second term is 6, 12. So each time we're multiplying by -2 times -2. Okay, so this time our pattern would be start at -3, next equals now, times -2. Okay, what about this one? 52, 46, 40. Our pattern here is that it's decreasing by 6 each time. So this time our recursive equation would be start at 52, next equals now, minus 6. Starting to get it? Okay, so what about the third way we can find a recursive equation? From a visual pattern. Okay, so here we have this. I've got a triangle, another triangle, term 3, it's 3 triangles, term 4, and we're looking at the sides in our perimeter. 3, 4, 5. What's happening to our sides? Well, each time our sides are increasing by 1. So our equation would be start at 3, next equals now, plus 1. Okay, so for this one I want 2 equations. I want one to represent the perimeter, and one to represent the area. Perimeter down here is represented in blue, and the area is represented in red. So for the perimeter, we can see it goes up by what each time? Here it adds by 4, by 4, by 4. So my recursive equation for the perimeter would be start at 4, next equals now, plus 4. Okay, so what about my area? Here it's 1, it's 2. So my recursive equation that represents area would be start at 1, next equals now, plus 2. So in this situation, I actually actually had two different recursive equations that represent the situation, the data. I was looking for two different things. So these are recursive equations. Every time, remember, you're going to do the start at and then the next equals now, and then your situation that you're dealing with.